Hello everyone, thanks for coming along. It's always a tough spot, last day, late afternoon, but I'll try and keep you amused for a little bit of that time. All right, happy plants and healthy soils. The reason I'm talking about using remote sensing to monitor changes in land condition over whole of a state is there's a variety of issues that we need to keep track of. Now, monitoring generalised, you've got to have a purpose for monitoring. Too many projects have been out there that have been out gathering data but not for a real purpose. So the key part of this story is you've got to have a purpose for what you're doing. You've got to have repeatable measures. You've got issues of sampling versus whole of population. You've got stratification that influences the way in which you analyse your data. You've got different benchmarks, and some of those might be absolute values or relative conditions, fixed or dynamic. You've got to be concerned about the frequency of observations. And if it's monitoring, you really want to make sure that whatever change you're observing is quantifiable. So why have we chosen remote sensing for some of this? Well, it meets the majority of those key requirements that I just discussed. And I guess the strongest part of this story is that it can do whole of landscape. The issues of subsamples representing broader landscapes have long been flawed in monitoring programs. Now, the remote sensing, many of the satellites are very good for measuring vegetation and soil condition. We have an archive for some of these satellites that go back 25, 30 years that we can analyse, and so we can look back in time. But I will acknowledge there are limitations, the timing and the scale at which these satellites operate. Sometimes these satellites don't fly over for 16 days until the next time they fly over. Other ones, they're quite small pixels that come over those 16 days of 25 to 30 metres. Other satellites pass over every day, but they're generally at coarser scales. It might be in the realms of 500 metres. So we've got to deal with some of that timing and scale. And they won't deal with some of the levels of detail. They're not going to show you the different varieties of wheat that are growing in your paddock or the different species of plant that you've got in your patch of native vegetation. I'm going to talk about two examples of some of the work that we're using satellite imagery to help address. One of them is the rangeland situation, monitoring the broad-scale production areas of the northern part of the state. And so we're looking at the issues of predominantly grazing in that landscape. We're looking at the primary productivity of those systems, because the vegetation is used by livestock, but also the values that might relate to the biodiversity in those areas as well. In the dryland agricultural landscapes, once again, we're trying to use satellites to analyse differences in soil conditions, where the greenness or response to the satellites are telling us that something's going wrong with the soils. And ultimately, it's coming down to the primary productivity and the different ways in which our crops and pastures are managed. Now, this is a point at which the audience normally tenses up because remote sensing talks are filled with a range of different things that worry people. About 90% of the population will have a fear response at this point in time, wondering what slides will come ahead. There is a smaller 10% that will experience a feeling of anticipation. So for today's talk, I'm going to try and deal with some of these issues of your fears and anticipations, but I won't be able to cover it all. These talks are often filled with extravagant use of the, 16.7 million colour palette that we have available to our GIS systems. Yeah, they're often filled with complex formulas where every Greek letter in the alphabet is used somewhere along the lines. Or they're filled with these beloved Python scripts and R statistics that are there to impress you and bamboozle you. Well, be reassured, the rest of this talk doesn't contain too much of these things that make you fearful. We hear about healthy soils, happy plants and healthy soils. So I thought I'd reflect on a relaxing moment with this CERT-P as a way you can relax. Don't get worried about the typical presentation. I'm going to rattle through some of these examples in a fairly cursory way. Contact me afterwards if you want to learn more of the details. But the first part of this story is getting a handle on the landscape stratification. In our case, we're using soil chemistry, topography, climate, land use, vegetation types as a way in which we can separate different land units in the system. So when we come to analyse the data, it's done in a much more meaningful way. We can look at the different landscapes, deal with the soil, pH, degree of inundation, the topography, the moisture, to allow us to come up with different units that represent similar ecological functions or productive landscapes. We do need to worry about some of the issues of what we're trying to measure over time of the dynamics of the system. In the rangelands, there are an unpredictable droughts and flooding rains kind of story, so you might need to deal with different ways in which you monitor. It's no point measuring it year by year because it might be a drought year or a good year. In the agricultural landscapes, our annual systems which allow us a bit more freedom to analyse year by year and perhaps over many years. The satellite products that we're using are based on the fractional cover data. Rather than getting too caught up in the complexities of these Landsat and MODA data sets, think of it as green vegetation, dry vegetation and bare soils. And across the state, these are the kinds of pictures that you would have for a longer time frame, 2008 to 17, where we have an illustration of the green vegetation, average green vegetation, or the total vegetation cover. Now, the concepts of using Landsat and the data that we use is quarterly Landsat composites and monthly MODIS composites. We're focusing on 2000 onwards, but predominantly the last 10 years. The timing and the perenniality of the greenness and vegetative cover signals indicate some of these landscape functions. The cumulative greenness values can give us a feeling for what the level of primary productivity is on those landscapes. And by using relative condition, as in comparing within a particular land system at a local scale, we can then increase the power of our analyses to look for changes that are happening at the local scale. Ultimately, we end up with a series of products of dry season cover, wet season cover. Through a stratification field, we can come up with measures of their relative dry season cover or responsiveness and health. We've used a 10-kilometre radius to make sure that the climatic variables are roughly the same within that window, and so we're not comparing the wettest parts of the Mount Lofty ranges with the desert landscapes. A whole range of products that relate to those kinds of outputs, but I'll skim over those. I'm only going to focus on the rangeland condition as part of this story, and we'll touch on the ag story if we have time. We're looking at perennial vegetation and annual vegetation systems, and we're probably using Landsat data because this is a longer term study. Because of that period of droughts and rains, we want an average over a number of years. And so we're aiming to identify the degree of utilisation of that dry plant cover and identify sites with degraded soils. Now this is part of the northeast of the state, classical pastoral country, fences, blue dots being water points, and a variety of spinifex plains and dune swale systems in this part of the world. Now we're stratifying this area by a combination of those surface water characteristics, soil, topography, and so on. And there's roughly 45 land unit types of this kind of world. We then have the cover data, the raw average mean cover over that particular time frame. We have the total vegetation cover, as in how much is persisting over longer time frames. Now, by using that stratification and using that 10-kilometre moving window, we can start getting a handle on the relative condition of those landscapes. And on this map on the right here, you start getting a feel for the degree to which the grazing, the blue dots, representing highest density of livestock numbers, are starting to have some influences on the relative condition of those vegetation types. So you have red dots appearing closer to water points where a lot of vegetation is being grazed away by the livestock. You also have other areas that have lower productivity that might be related to soil properties, and that might be salt lakes or those sorts of things. We can start quantifying that data in terms of what proportion of the landscape is utilised strongly by the livestock that are grazing over those systems. And so these are charts representing that data set for a variety of stations, showing the number of square kilometres in each of those utilisation classes. It can be expressed as a proportion of the property or in square kilometres, depending on the purposes of your monitoring and management program. So you're starting to get some quite powerful analyses of what proportions of these properties would be prone to changes in management that can be used to set stocking rates or improve the education that you might provide in those areas. In the soil productive, so I'll go back one. The map on the right here, you can also be utilising the amount of greenness response after rains as well. And so if those red zones that are currently heavily utilised green up nicely, then they're a good indication that the soil is still intact and the soil seed bank is intact. So although this is the total vegetation cover, the red spots might be of concern. You may also be interested in whether the soil is also being degraded in those areas or it has the ability to bounce back. In the agricultural areas, we're looking at annual vegetation systems, crops and pastures, some of the perennial vegetation stories. We use Landsat imagery for the longer term imagery, but we also use MODIS imagery for the shorter term story. And that's where we use a hybrid of downscaled MODIS imagery, the monthly data, to the same patterns that we're identifying from the Landsat imagery, and that increases our ability to work out the productivity of those particular spots. We end up with similar products to those that I've described for the pastoral areas, where you have the total vegetation cover and then indicators of where the productivity may be much less from either management or soil properties, and so we'll investigate a bit further. And I'll leave it that with a quiet reflection on the happy plants that ultimately that we're trying to look after.